evaluate. When I plug in infinity, I get infinity times tangent of 1 over infinity, which is tangent of 0. That's 0. Okay, I have to move one of them in the denominator. Definitely move the x to the denominator. So here we go. Limit as x goes to infinity. So I'd have this tangent of 1 over x that stays here. Move x to the denominator as 1 over x. Check it. If I get tangent of 0, which is 0, 1 over infinity, which is 0. Yes, it's L'Hopital ready. So I'd get secant squared of 1 over x, and then a negative 1 over x squared over a negative 1 over x squared. Well, that's pretty beautiful. Those things just go right away, canceling. And so now let's see what happens when I plug in infinity into here. 1 over infinity is 0, secant squared of 0. That's 1. All done. Notice I'm not writing like 1 over infinity, like all that kind of thing. This is just what you think, right? You don't write that. I just want you to be a polished mathematician. So let's do number 4 here. It's not a fraction. When I plug in infinity, I get infinity. And since that's a negative exponent, that would be like a 1 over infinity. So that's like a 0. So this term here is screaming to go in the denominator because it's got a negative exponent. So now if I look at this, oh, that's infinity over infinity. Now I'm ready to do L'Hopital. So I get 1/2 x to the negative 1/2, 2e to the 2x. Take the time to rewrite it. It's so important. So this really in the numerator is like 1/2 1 over root x over 2e to the 2x. Take your time, take some steps if you want, because this down here is like a fraction, right? This fraction divided by this fraction. So I'd get 1 over 2 root x, and then this would be like 1 over 2e to the 2x. Well, look at all the infinities down here. That's infinity, e to the infinity is infinity, infinity squared is infinity, 1 over infinity is 0. Okay, so now let's move on to these other kinds of problems, like number 6. So if I put in the 0, I get cosine of 0 is 1. 1 over 0 is infinity. I get 1 to the infinity. That is an indeterminate form. So this is where you have to take that bold math step and start with let y equal cosine of x to the 1 over x. And that parentheses is important, right? Then I'm going to take the ln of both sides. ln cosine of x to the 1 over x. Be really careful not to skip steps because it's usually in this first step right here people make mistakes. Then take the time to pull that down in the front. 1 over x ln cosine of x. Okay, I don't need parentheses anymore, right? Because it's ln of cosine. Now we pull the limits back in. Limit as x goes to 0. ln of y, oops, tried to keep it color coordinated so you can just see. ln of y equal limit as x goes to 0. And you know I'm looking to use L'Hopital, so why don't we just write that as the fraction? Now let's check and see. Is it L'Hopital ready on this right-hand side? Cosine of 0 is 1, ln of 1 is 0, 0, 0, yes. So let's do it. 1 over cosine times the derivative of cosine is negative sine. Derivative of x is just 1, so this gives me 0. Okay, so what does that mean? The limit as x goes to 0 of ln of y is 0. So I can conclude, I can say now, the limit as x goes to 0, and you can say y, or you could say rewrite that original thing, but that it's e to the 0. So that's 1, right? So important last step to take e of the answer since you took ln in the beginning. Number 7 is really similar. So let's do it. So I see if I put in infinity, I get 1 to the infinity. That is an indeterminate form. So you start with your bold math step. So bold math step is let y equal Okay, then the next thing you do is you take the ln of both sides. So ln, trying to get blue here. Okay, ln. Okay, so let's carry everything else along. So ln of y equal, and again, I'm going to encourage you just to go slow. Then bring this x down in the front. X, and then ln 1 plus 2 over x, and then this ln of y. Okay, now I'm going to pull the limits back in, right? So I'm going to say limit as x goes to infinity. Let me do it in the next line. Limit as x goes to infinity of this ln of y. And then limit as x goes to infinity. The last one had a nice way to make it a fraction, but oh, this doesn't really. I have to think about this. So let's think about it. If I put in infinity, I'd get infinity times ln of 1, which is 0. What do we do with infinity times 0? You know, we put one of them in the denominator. Never put the x guy in, or the ln guy in the denominator. So we want to move this one to the denominator. So let's move slow. So I'd have ln 1 plus 2 over x over 1 over x. All right, now I'm going to take the derivative because, oh, check it. Is it L'Hopital ready? If I put in infinity, I get ln of 1, which is 0. 1 over infinity, which is 0. It is L'Hopital ready. So let's do it. So if I take the derivative of the numerator, you see the chain rule, right? So the chain rule would be 1 over stuff times the derivative of stuff. And the derivative of 2 over x, again, if you have to do it on the side, so 2 over x is like 2x to the negative 1. So that would give me a negative 2x to the negative 2. So that's the derivative of the numerator. Then I've got the derivative of the denominator. That's negative x to the negative 2. So you're looking, oh, I see those things canceling, right? Except for a negative 2. So limit as x goes to infinity, I'd have a negative 2, 1 plus 2 over x. Now plug in the infinity. 2 over infinity is 0. So this whole side, I get negative 2. Okay, where did that come from? Oh, right, I'm doing this. So the limit as x goes to infinity of ln of y is negative 2. So the last step would be to say the limit as x goes to infinity of y is e to the negative 2. That's the answer. And don't trust these answers, so down here. All right, I think I have 2 more, and I'll do those in the next video.